In this one, we want to evaluate each integral using blah, 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 blah. Same dealio. Okay, now this one we won't have to do anything fancy. We just need to figure out what the antiderivative is of sine is. And we can check our cool calculus card to help us out. It's right down there. Now, some things you'll be able to just kind of like swap. So the derivative of sine is cosine. So to go backwards, yeah, it's negative. Derivative of sine is cosine. So if we have sine, then it should switch back to cosine. So it's going to be negative cosine of u plus c. So negative cosine of u, but it's just x. And we're going from 0 to pi. So plug them in. So we get negative, and I didn't do the plus c because it's a definite integral. So I do the top, cosine of pi, minus the bottom. We might get something this time, so I'm just going to do plus cosine of 0, because I think cosine of 0, yeah, cosine of 0 is 1. And then the cosine of pi is negative 1. So that is 1 plus 1, that's 2. Okay, we can check that on our calculator as well. So on my calculator, I just typed in sine x. I did a zoom trig, just a reminder. So zoom trig to get this one. Nope. Okay. So I've just typed in sine x into my calculator. Make sure you're in degree mode. The first time I did this, I was not in degree mode, and it caused all kinds of trouble. So you want to? I did a zoom trig to get my graph here. Bup, 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 bup. Okay, and then I would like to integrate this. So second calc, integrate from 0 to pi. Whoop! And we get 2. Ah, nice. Now, in this one, they've actually given us a chunk where we're trying to find. So to find that area, it is going to be the integral from 1 to 2. So from 1 to 2 of 1 over x squared. And we're going to find the antiderivative with respect to x. So I don't really like having that 2 in the denominator. Let's just make it that. That'll be a little simpler to figure out. Dx. So we integrate that by adding 1. So that's x to the negative 1 divided by our new exponent, which is negative 1. And then we're going to check that from 1 to 2. Okay, so really that is negative 1 over x, checking that from 1 to 2. We do the top part, so that's negative 1/2 minus what our bottom part is. Whoop. Also negative 1, negative 1. So that is negative 1/2 plus 1, which is 1/2. So the area of that region is 1/2. There where you can see it. All right. All right, now this one is a weird one, like 3 to the x. If I check my cool calculus card, that one is not on here. So, like, if I check my antiderivative section, I don't have that one. I have the derivative of a to the u, but I don't have the antiderivative of a to the u. And it doesn't just work out nicely like that. So this one, what I would recommend you do, grab your good friend the Larson book. And in the Larson book, like right when you open in the front cover, there is a large collection of basic integration formulas. So this 3 to the x we don't need to know. But we can still use the property in this book. So it is number 7 in the Larson book. So it is 1 over a. So this is our a value, the 3. So this is 1 over, the ln of a. So that's 3. Times a to the u, which is 3 to the x, because our x is u. And then it's got a plus c, but that plus c is for an indefinite integral. We have a definite integral since we have those numbers there, so we don't need the plus c. But we do need to evaluate this from 2 to -1. Thanks, Larson Book. You're so helpful. Okay. So that is 1 over the ln of 3 times 3 to the -1 minus the 1 over the ln of 3 times 3 squared. So that is 1 over 3 ln of 3 minus 3 squared over ln of 3. At this point, I really should stop, but once I start simplifying, I just can't. So that is 3 minus, no. It's 1 minus 3 cubed over 3 ln's of 3, which equals 3 cubed is 27. Yep. 1 minus, I don't know why I had to think about that. Negative 26. 26 over 3 ln's of 3. So that'd be the exact value. Your calculator would spit out some decimal, but you could check your decimal against that fraction. Neat. But again, you don't need to memorize this. Nah. So in this problem, I got secant squared over tangent squared plus 1. Oh, man, that's a lot of stuff. But wait a minute. Tangent squared plus 1. That seems like a thing. I wonder if the Larson book has anything to say about that. Let me take a look. Because I remember something like a Pythagorean identity. If I turn the page out of my Larson book and I check the second page, there's a unit circle and I throw up in my mouth a little bit. But it also has the Pythagorean identities on the side. And well, I doubt you can see that, but on the side it has the Pythagorean identities. And one of them is that tangent squared plus 1 equals secant squared theta. Oh, cool. Thanks, Larson Book. You're so helpful. So we could rewrite this thing instead of all this gobbledygook of 0 of pi over 4, the integral from 0 to pi over 4 of secant squared theta over secant squared theta. Ah, cool. Well, hey, that's just the integral from 0 to pi over 4 of 1 d theta. So I guess the antiderivative will be theta. Neat. From 0 to pi over 4. So then to finish that integration, we have to subtract those two. So that is pi over 4 minus 0. So it's just going to be pi over 4. Huzzah! The big trick about that one is being able to spot this. I think that's pretty sneaky. So that's kind of a big brain moment right there to be able to spot that. But because like otherwise we don't really have anything to do with secant squared and all that jazz.